Okay, so today we're going to talk a little bit about squares and square roots as a review. We've been going over exponents and different rules. So today we're going to introduce the idea, or maybe it might be a review for some of you, of what a square versus a square root is. So first, let's take a look at just some of the things we've talked about with exponents already. All right, so if we have this example here, 3 to the 5th times 3 to the 4th, we want to write this using positive exponents. So the rule that we learned is here we're multiplying two powers that have the same base. Right? So if we're multiplying two powers with the same base, like this, x to the a times x to the b, well, I can keep the base the same and just add the exponents together. So if I take 3 to the 5th and I'm multiplying it by 3 to the 4th, 3 to the 5th literally means I'm doing 3 5 times. And 3 to the 4th is 3 another 4 times, right? So altogether I have 3 5 times and 4 times. So that's why we can add those exponents together. So when I combine 3 to the 5th times 3 to the 4th, I have a total of 3 being multiplied 9 times. So the correct answer is C, 3 to the 9th power. And this rule also holds if we have multiple products that we are multiplying together. So if I take 5a squared and I multiply it by negative 7a to the third, first I want to do is rewrite this so all of my numbers are being multiplied together, and then put my variables together so that I can combine those using our multiplication rules. So I'm doing 5 times negative 7 in one group, and a squared times a to the third in another group. So positive 5 times negative 7 would be negative 35, and a squared times a to the third, because they both have the base of a, I can add 2 plus 3 for the exponent to get a final answer of negative 35a to the 5th power. So the correct answer here is A. So by multiplying 5a squared and negative 7a to the third, I get negative 35a to the 5th. All right, so we've also talked about how to divide with exponents and what to do if we end up with negative numbers. So remember, like when we took, if we have bases with exponents that are being divided, the shortcut is that I can take those two exponents and subtract them. So I can do a minus b. And it's important that it's always the numerator first and then the denominator second. It's always the numerator minus the denominator. So if we take x squared and divide by x to the 6th, remember if we were to write this out, that would be like x times x in the numerator and then 6x's in the denominator. So if I start canceling these out, 1x there, 1x there, 1 there, 1 there, well, what I have left is, in the numerator, all I have left is 1. In the denominator, I've got x to the 4th power. Right, so x squared over x to the 6th, if I write it out, I see I get 1 over x to the 4th power. Well, what if I use my subtraction rule? So in this case, I would keep x as my base, and then I'm going to subtract the numerator, 2, minus the denominator, 6. So 2 minus 6 is actually what? Negative 4. Now, this was where we went into our negative exponent rule. If I have a negative exponent, I make it positive by making the reciprocal of this expression. So x to the negative a is actually over 1. So I do the reciprocal, 1 over x, and then when I make that reciprocal, the exponent becomes a positive number. So x to the negative 4th, as we can see, is actually the same thing as 1 over x to the 4th. And since they want me to write this using positive exponents here, I would rewrite x to the negative 4th as 1 over x to the positive fourth, meaning the correct answer is D. All right, so that was just a quick review of how to work with exponents, some of the exponent rules that we've gone over. Today we're going to look at is we're going to be finding the square roots of numbers. Okay, mostly we're going to be looking at perfect squares. And then we're also going to estimate the square roots of non-perfect squares. So we're going to be finding the square roots when we have perfect squares, and we're going to be estimating the square roots of anything that is a non-perfect square. So let's look at some of the vocabulary here. First off, what is a perfect square? So a perfect square is when we have an integer or a rational number. I'll take this a rational number that is raised to the second power. Raised to the second power. Okay. So think of a rational number. A rational number is things like their whole numbers, so 1, 2, 3, 4, and so on. Okay. Rational numbers could also be fractions, so 1/2, 3/5. Okay. Rational numbers could also be negative numbers, -3, -4, -5. And they could be decimals, 1.5, -1.5, and so on. Okay, so these are all rational numbers. Whenever we take any of these numbers and we raise it to the second power, our result is what we call a perfect square. So we're mostly going to be interested in today is integer, perfect squares of integers. Okay. And integers would be things like taking 2 and squaring it. So what do we get when we do 2 squared? Well, 2 times 2 is 4. If I do 3 squared, that's 3 times 3, or 9. 4 squared, 4 times 4 is 16. What if I had negative, because negative numbers are also integers. What if I did -2 squared? Well, -2 times -2 is still going to give me +4. Right? -3 squared is +9. -4 squared is +16. So both positive and negative integers result in positive perfect squares. And that's what this column here, the result that I get here, 4, 9, 16, right? Those are the perfect squares, okay? So what is a square root then? The square root is the, let's see how to explain it. The square root is the opposite, basically one way to think about it. It's the opposite of squaring a number. So if you think about math, everything that we do in math usually has some sort of opposite or inverse. Okay? Square root is the inverse. So if you think about it, addition and subtraction are inverses. Multiplication and division are inverses. Well, exponents have inverses also, and those are roots. So we're looking specifically at square roots today. So that's the inverse of squaring a number. So if I take any number and I square it, okay, x squared is equal to a number. The square root is what undoes that. So if I take the square root of a number, it gives me back to my original number. Okay? And the square root is shown by using what's called a radical sign, and that's this symbol here. It looks like a little check mark. Okay? That's a radical sign. So we're going to be looking at perfect squares, taking the square root of them, and then the radical sign is the symbol that we use for creating a square root. So here's a good definition for what a square root is. So when we talk about a square root, the square root of a number is one of its two equal factors. So when you think about the word factor, remember factors times each other. So if we have two factors, those are the parts of the multiplication problem that give us a product. Okay, so when I take the square root, I'm looking for two factors that are the same. Okay, I'm looking for two factors that would be the same to get a product. Okay, so let's take, for example, let's just do 16. So what are the factors of 16? Well, I know I could multiply 1 times 16 and get 16. I could do 2 times 8. I could do 4 times 4. And those are all my factors that would give me 16. If I'm looking for the square root of 16, I'm looking for which of these sets of factors are the same. 1 and 16 are not the same, 2 and 8 are not the same, but 4 and 4 are the same. So I could say that 16 is equal to 4 times 4. Well, knowing our rules for exponents, I can say 4 times 4 is actually 4 squared. Okay. So if I'm looking for the square root of 16, I'm looking for one of its two equal factors. Well, I know 16 is made up of 4 and 4, 4 times 4. So when I take the square root of that, it leaves me with one of those 4s. Okay. So what we're saying is if we start with a number, x, and I square it, I get a new number, y. If I want to get back to my original number, I need to undo or do the inverse of that process. So I take the square root of y and it gets me back to x. Just like starting with 3. If I add 5 to 3, I get 8. Well, how do I get back to 3? I need to take away that 5 or do the inverse to get back to 3, right? So this here is an inverse, just like these are inverses here. All right, so let's take a look at just some basic examples. So what is the square root of 64? Well, if I want to know what the square root of 64 is, I need to first figure out what are the factors of 64. So what numbers can I multiply by each other to get 64? Well, I could do 1 times 64. I could do 2 times 32. I can do 4 times 16. I can do 8 times 8, and then I start reversing myself. I can start going back 16 times 4, 32 times 2, 64 times 1, so I don't need to repeat it. So now if I'm looking for the square root, I'm looking for those factors that are the same. Well, that's not 1 and 64. It's not 2 and 32 or 4 and 16. 8 times 8 is two factors that are the same. So 64 is 8 times 8 or 8 squared. So if I'm looking for the square root of 64, I'm looking for one of those factors. I'm looking for the square root or the root of 8 squared. And remember, roots undo that squaring. So the square root of 64 in this case is going to be the opposite of 8 squared, or it's just going to cancel each other out. It's just going to be 8. All right, what about this one here? This square root of 121. But if you notice, this one has this little negative sign out front. So this indicates that we're looking for the negative root of 121. So remember back to what we were saying before, when I square numbers, right? If I do 2 squared, that gives me positive 4. Well, if I do negative 2 squared, it also gives me positive 4. So all square roots have both positive and negative roots. Okay? Every root or every number has both a positive root and a negative root, because a positive times a positive is a positive number, as well as a negative times a negative also gets me a positive. Right? So I could have two numbers that are the same, multiply each other, both of them are positive, or both could be negative. So if I start with 121, I want to start listing out the factors of 121. Well, I know that's going to be 1 and 121. It could also be 11 and 11. But what else could it be? It could be negative 1 and negative 121. That would get me positive 121. It could also be negative 11 times negative 11. So I see that 121 could be 11 squared, or it could be negative 11 squared. And in this particular case, I'm interested in the negative root. So the square root of 121 I know is 11, right? Because it's one of those factors. But in this case, I'm interested in the negative version of that. So that would make this, the negative square root of 121 would be the negative factor, or it would be negative 11, because negative 11 squared is still going to get me 121. So my answer is negative 11. So just keep that in mind, that every root, whenever you take the square root, you could get both positive and negative versions of it, and they'll let you know which one they're interested in. In this case, they were interested in the negative root of 121. All right, so this one says find the positive and negative roots of 256. So this means we're looking for both roots. We're looking for the positive root and the negative root. So I need to figure out 256 is going to be what has a square. Well, if you know your multiplication tables, usually we learn them up to, what, 12, right? I know 12 squared is 144. So then it's just a matter of doing the math beyond that and seeing what I get to 256. If I do 13 times 13, that gives me 169. Okay. 14 squared, 14 times 14 is 196. 15 squared, 15 times 15 would be 225. And 16 squared, if I do 16 times 16, you'll see that you get 256. So 256 is equal to 16 times 16, or 16 squared. So by taking the square root of 256, right, I'm interested in one of those factors. So the square root of 256 could be 16, right, because that's one of the factors. However, 256 could also be negative 16 squared, right? Negative 16 times negative 16 would also give me positive 256. So the square root of 256, the positive root, is 16. The negative root of 256 would be negative 16. And what this symbol up here is telling me is that they want both of them. So the positive and negative roots of 256 are positive and negative 16. Erase that there. So it's both positive 16 and negative 16. Okay, fine. What about the square root here of negative 9? Well, I can start this the same way. I'm looking at the factors of negative 9. Well, the factors of 9 would be 1 and 9, or 3 and 3, right? But notice, if I want negative 9, think back to our rules for positive and negative numbers. What makes a negative number? Well, it could be a negative times a positive. That'll give me a negative number. Or a positive and a negative. Doesn't need necessarily be 1. Didn't even write that. All right. Positive and a negative would also be a negative. So one of the factors has to be a negative and one has to be positive. So it could be negative 1 times positive 9. It could be negative 3 times positive 3. It could be positive 3 and negative 3. Or it could be positive 1 and negative 9. All right. Now I know, because I'm looking for the square root, I'm looking for factors that are the same, which leads me to think that it should be one of these two groups here, right? 3, because these are all 3s. but careful, because what is this? Negative 9 is equal to either 3 times negative 3, or it's negative 3 times 3. Neither one of these is equal to 3 squared or negative 3 squared. Neither of these factors are the same. 3 times negative 3 is not the same thing as 3 times 3. Negative 3 and 3 is not the same as negative 3 times negative 3. So this leads us to a particular rule here in the real number system. So for algebra, what we do is if we had the square root of a negative number, square root of any negative number, okay, has, for our particular purposes here, has no real solution, because there are no two real numbers that would multiply together to get a negative number. One of them would have to be positive and one would have to be negative. Okay? And so for algebra, we can't take the square root of a negative number. There is no number multiplied times itself to end up at a negative number, because again, one of the factors would have to be positive and one would have to be negative. So for this one, the square root of negative 9 has no real solution. And for you right now, anytime you have the square root of a negative number, you can't get that at this point. So there's no square root because no number times itself is equal to negative 9. All right, so let's have you run through a couple of these practice ones here. So what would be the square root of 25? All right, you should have gotten 5 because 25 is 5 squared, right? So by taking the square root of 25, I'm interested in one of those factors. So in this case, it's 5. And because there's no symbol here, it's understood that we're looking at the positive factor of 25. So the positive factor of 25, the positive root, is 5. All right, here you're looking for the negative root of 144. And you should have gotten negative 12, okay? Because again, we know that 12 squared is 144, or negative 12 squared is 144. So when I take the square root of 144, I know it's going to be either 12 or negative 12, and since we're interested in the negative root, my answer is negative 12. All right, for this one, find both the positive and negative roots of 16. All right, you should have gotten both 4 and negative 4. And again, that's because we're looking for both the positive and negative roots. So I know to make 16, I could do 4 squared, or I could do negative 4 squared. So when I take the root, the square root of 16, that could be either 4 or negative 4. And in this case, we're interested in both of them. So it's both 4 and negative 4. And finally, find the square root of negative 64. And the correct answer is that there is no real square root, because we can't, for it to be negative 64, it would have to be 8 times negative 8. Right? There's nothing that would multiply times itself to get a negative number. All right, so all the examples that we worked on before were perfect squares, okay? But now what we're gonna look at is estimating square roots of things that are not perfect squares. So if I take the square root of 22, right? It's not going, 22 is not the result, right? Well, let me start over here. If I think of the factors of 22, if we list it out like we did on the other problems. What are the factors of 22? Well, I could do 1 times 22, I could do 2 times 11, and that is about it. Right? 3, 4, 5, there's nothing else that I multiply together to get 22. So looking at this, are there two factors that are the same? And the answer is no. I'm not multiplying something times itself to get 22. So 22 is not a perfect square. Okay, so my answer is not going to be an integer or a rational number. So when I take the square root of 22, it's going to give me what we call an irrational number. Right? It's not going to be a terminating decimal. It's not going to be a fraction, a positive number, or a negative number. In fact, if you were to type this into your calculator, you would see the square root of 22 is it's a decimal that just doesn't repeat and it doesn't end, it just keeps going. All right, so what we want to do instead is we want to estimate where the square root of 22 would be to the nearest integer. And again, integers, remember, things are positive numbers, negatives, 0, 1, 2, 3, and so on. All right, so they're those positive and negative counting numbers, or 0. So what I want to do is I want to figure out what are the integers, what are the perfect squares that would get me closest to 22. So I could start at 1 and do 1 squared is 1. 2 squared is 2 times 2, or 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And here what I notice is that 22 would fall in between 16 and 25, right? So I could say 16 is less than 22, which is less than 25. So 22 is between 16 and 25. Right? But I'm not interested in 22, right? I'm interested in the square root of 22. Well, it makes sense, or it should make sense, that the square root of 22 then is between the square roots of 16 and the square roots of 25. So it should be between, I don't know why it keeps doing that. It should be between the square roots of 16 and 25. Well, I can find the square root of 16 because it's a perfect square. And I can find the square root of 25 because it's also a perfect square. The square root of 16 is 4. The square root of 25 is 5. So I can assume that the square root of 22 should be between 4 and 5. All right, so I've kind of created this boundary for myself so I know what numbers, which integers it's between. What I'm interested in now is which one is it closest to, the nearest integer. So is it closer to 4 or is it closer to 5? Well, for that I can look back here. All right, 22 is 6 away from 16. It's 3 away from 25. So 22 is closer to 25, which means the square root of 22 should be closer to the square root of 25, which was 5. So the square root of 22 should be about 5 if I'm rounding to the nearest integer. And if you were to put this on a number line, you'd kind of be able to see it also. Right? Here's 4, which is the square root of 16. Here's 5, which is the square root of 25. 22 on this number line is much closer to 25, so the square root of 22 should be closer to positive 5. So the answer is that the square root of 22 is closer to 5. All right, here's the same idea. I've got 319, but the only difference now is I'm looking for the negative root. Okay, so again, 319. Right? I need to figure out what integers, because it's not going to be a perfect square. I want to figure out what is it closest to. Well, if you think back to a couple problems ago, we figured out that 16 squared was 256. Right? 17 squared is going to be 289. And 18 squared is going to be, let's see, 18 times 18, we'll just do that quickly, 324. So 18 squared is 324. So that shows me that 319 fits in nicely here between 289 and 324. Okay, so I could say 319 is between those two perfect squares, 289 and 324. So when I take the square roots of those, right, the square root of 319 should be between the square roots of 289 and 324. And I know the square root of 289 is 17. And the square root of 324 is 18. Okay. So then it's just a matter of which one is it closer to. Well, 319 is 30 away from 289, and it's only 5 away from 324. So it's much closer to 324, which means the square root of 319 is closer to 18. So it's about 18 if we're looking at integers. But if you remember, what are we looking at? We're looking for the negative roots. So that means the negative root of 319 should be about negative 18. And if you want to look at it on a number line, it's the same idea, it's just reversed around, right? Negative 18 is the negative root of 324, and negative 319 is a lot closer to that than it is to negative 17. So the correct answer is negative 18. All right, so your turn to give it a shot. Estimate the square root of 71 to the nearest integer. And the correct answer should have gotten you 8. And as you think about it, 71, 8 squared is 64, 9 squared is 81, so 71 is between there. Right? And it's 7 away from 64, it's 10 away from 81, so it's a little bit closer to 8. And we'll try this one, estimate the negative root of 38 to the nearest integer. And you should have gotten negative 6, because if we're looking at 38, we're looking for what it's close to. Well, it's between 36 and 49, so 38 is in between 36 and 49, and it's a lot closer to 36 than it is to 49. So the square root of 38 is closer to 6, which means the negative root of 36 is going to be closer to negative 6. All right, so that's what covers everything that we want to do today. We found the square roots for perfect squares, right? And we found that when we take the square root of something, it could be positive, it could be negative, or it could be both, right? And they'll specify. All right, then we also estimated square roots to the nearest integer, right, by finding out non-perfect squares, what they were closest to. So we estimated non-perfect squares to the nearest integer by figuring out what was the closest perfect square that they were closest to. Right? So example was square root of 22 was in between 16 and 25. So when we took the square root of 16 and 25, we found that the square root of 22 is between 4 and 5, and it's closer to 5. So the square root of 22, we could say, is about 5.